All right, so if you're seeing my screen, you see evaluate each expression. Your
Yep.
calculator has a factorial button, that exclamation point there.
Oh yeah.
If you don't have that, you can just write 6 times 5 times 4 times 3 times 2 times 1. But depending on you know, how much time you have, you definitely want to just use a calculator for this. Let's see if I can tell you where it is if you don't
It's
know.
under math and then probability.
Okay, so as long as you know where it is, that's what's key. So
Okay.
you should get 120 for that. Number two is in your calculator. You have to put this number in first, 7, and then there's an NCR. It's probably in the same place, and then a 3, and you get your value out. Now you have to tell me if you want us to do these by hand to show you how to do them by hand.
Could we just go over how to do it by hand real
Sure.
quick?
So there's a formula here for NCR. It is n factorial. I'm sorry. Yeah. N factorial over n minus r factorial times r factorial. So the n is 7 factorial over 7 minus 3 factorial times 3 factorial. So that, for example, you could put in your calculator, but there's more to simplify here. So it's 7 factorial over 4 factorial times 3 factorial. Okay. And then depending on how comfortable you are with this, it's 7 times 6 times 5 times 4 factorial up top. And then this 4 factorial you put down here. So these cancel. 3 factorial is 3 times 2 times 1. That's this part over here. That's 6. That cancels with that 6. And you get 7 times 5, which is 35. Let me know if I need to repeat any of that. So for the last one, permutations, it's a slightly different formula, but again, it's in your calculator as well. So you don't have to do this by hand unless you somehow think that the test will require you to do that. So the formula for NPR is n factorial over n minus r factorial. So you can see it's really similar to this one up here on the right. It just doesn't have this r factorial. So you may want to choose the strategy where you put it into your calculator, get the value, and then see if you get something that matches when you do it by hand. So we have 11 factorial over 11 minus 9 factorial. So that's 11 factorial over 2 factorial, and that's quite big. So definitely want to put this into your calculator. Go ahead.
Yeah. Okay. I got 199,584,000. Okay.
And something. Okay. All right. So that takes care of that. Those 3 questions there. All right. Number 4. P and Q. So the probability of Q, what did I ask for? Q and R. Okay. So they're independent, which means that you multiply. So the probability of Q and R, that's the symbol there, is 0.5 times 0.4. You just take these two numbers and multiply them together.
Oh.
0.2. And number 5 is very similar. You simply multiply the two numbers together. Let me get that snipped in. So the probability of Q and R is 1/3 times 3/8. The 3's cancel and you get 1/8.
Okay. Got it.
All right. Number 5, I'm sorry, 6, 7, and 8, they refer to this table. Your table is given in the book here. What they don't give you is the total. Usually the totals are also given here. And you have to total vertically, so that's like 19, That's 30, and then you total horizontally. So that's 25, that's 24. And then this is, I call this your super total, or your total of your totals. It's all of it's the number of participants. And you can either find it by adding vertically or horizontally. You should get the same number though for each. So there's 49 total.
Okay.
Okay. So for number 6 is the probability of 5 or more. 5 or more is this column here. So how many are in this column?
30.
30 out of the total 49.
Okay.
Number 7 is the probability of 5 or more, and then that vertical bar means given age is less than 30. So the way you interpret this is you figure out, well, what does that second part mean? What is the age less than 30? Well, that's this row right here. I keep circling here. So in that row, it's out of 25 because that's your total. In that row, how many are 5 or more?
18.
18. So what this does is it changes this number down here.
Okay. Yeah, that makes sense.
8. The probability of age being greater than or equal to 30 given 0 to 4 groups. So you look at the 0 to 4 groups, and that's this column. So these givens generally focus you on one row or one column. So this time, the column has a total of 19. Well, how many are greater than 30? 12.
Okay.
So is that something you think you can do on your own?
Okay, so for number 8, we did it out of the
Column.
columns.
Yes, but how many are 0 to 4? 0 to 4 is this column, 19. How
Oh,
many are
okay.
age less than 30? That's this row, 25. So these givens reduce you down to a row or a column.
Okay. Yeah, that makes sense.
Okay. If you need more than that, we can do more examples. You just tell me what you want.
Yeah. Okay.
All right, so number 9, 2 standard cubes are tossed. State whether the events are mutually exclusive. One of the numbers is 1 less than the other. The sum is odd. So mutually exclusive means that they cannot occur at the same time.
Mm-hmm.
Cannot occur same time. So to prove that this is not mutually exclusive, you just need to find something that works. So you're throwing 2 dice. So for example, if you got a 3 and a 4, is one of the numbers 1 less than the other?
Yeah.
Is the sum odd?
Yes.
So these happened at the same time. So these are not mutually exclusive because they can happen at the same time. So the way you would explain that in an exam is you would want to give an example. The best thing to do is give a counterexample when it does not work. And that's because proving that they are mutually exclusive, you almost have to show every possibility, which can be hard.
Yeah. Okay.
Okay, so let's look at 10. These are sort of strange. I don't think you'll get this on a test.
Mm-hmm.
Mutually exclusive is I think they would use different examples. Sometimes they actually ask you to come up with something that's mutually exclusive. But okay, the sum is greater than 10. So you have 2 dice. So the biggest sum is when you have a 6 and a 6, 6 and a 5, or a 5 and a 6. 6 is one of the numbers.
Okay.
So this is always true. So this can happen.
Yeah. So I just have to give all of the examples of when the sum is greater than 10 and fix it. Like that's just what.
Yeah, that would be the way of doing it.
Okay.
I generally prefer things that are sort of like we think of things like the lights. They're either
Mhm.
on or off. These are mutually exclusive. Like they can't happen at the same time.
Okay.
Those are the kinds of things I think of that are much more a door is either open or closed. These are things that are kind of there's no overlap.
Yeah.
No overlap, and that's really what we're like. These overlap.
Mhm.
There's sixes there, and the sum is greater than 10.
Okay.
I'm surprised they didn't give you one that isn't, but they
Mhm.
did not. Okay. All right. Number 11. So number 11, uh, the the way you find Q1 and Q3, it depends on whether you have an even or an odd number of numbers. These are already sorted for you, which is nice. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 numbers. So this is the harder case because there's 10 even numbers. So the first thing I would tell you to do is break it in half. 1, 2, 3, 4, 5, like that. Okay. And then 1, 2, 3, 4, 5. So your Q2, which I know it's not asked for, is right there. It's the average of those. Okay.
Okay.
Q1 is the middle number here, which is 42, because there's 5 numbers. Whenever there's an odd number of numbers, it's right in the middle. That's Q1.
Got
Q3
it.
is the middle number on the right. So once you break
Mhm.
this set in half, you just look right, what's the middle number, left, what's the middle number. But if there's an even number of numbers, you'd have to take an average, which we don't have here. So let me just briefly describe that, and I'll just reuse some of the numbers here: 36, 38, 42, and 47. So the divide. And this is not 12. This is like 11, number B. The dividing line is right here in the middle. So the Q1 is the average of these because there's an even number of numbers. Up here there was an odd number of numbers.
Mhm.
So the Q1 would be the average of these: 36 plus 38 divided by 2, which is 37. And then Q3, because there's an even number of numbers, it's an average of this here, for that. Is this clear, or
Okay.
is it because it? Um, if there was more numbers on the outside of these, you would still just go to the middle 2 numbers and find the average.
Yeah,
Okay.
that makes sense.
All right. Moving on now to number 12. Open-ended. Okay. At a local high school, there are 150 student parking spaces in the parking lot. There are 200 applicants for parking permits. Describe a way that the permits can be assigned fairly. Okay. Um, the usually they don't want an open-ended question on the exam. It would be more like how many possibilities are there?
Mhm.
So when you think about parking situations, does it matter who parks where? Like if you have a car here and someone else has a car there, or you have a car there and they have a car there, does that really matter?
No.
You're all in the parking lot. So an order does not matter. That is considered a combination.
Mhm.
So it's 200, choose 150, because you have 200 cars or applicants and only 150 spaces.
Yeah.
Okay. Now this wants something different. It says describe a way that the permits can be assigned fairly. Basically, it's like how do you prevent it so that it's how do you make it random?
Yeah.
So did you talk about this at all in your book? Like, did you talk about random numbers or how to?
Yeah, like random number generators, I guess.
Okay, so like
Something like that could work. I don't
yeah,
know.
so let's just say you everyone was numbered, had a number. Uh, let's say everyone was numbered 0, 0, 1, all the way up to 200. You could go to a random number table. Okay, and you could pick blocks of 3 numbers, and if it's in this range, you would say check, they get one. But if it's like, let's say it was 123, but if the next 3 were 456, that would not work because it's too big.
Mm-hmm.
And then let's say the next one was 014. Well, that person would be okay.
Yeah.
So that's a way you could do this
Okay.
to make it fair.
Yeah.
Okay, moving on to next set of questions, 13 and 14. For 13 and 14, they tell you that a data set has a mean of 29 and a standard deviation of 4. So you have to be able to draw a normal distribution curve, nice one like that. You cut it in half, and that's 29. One standard deviation from the mean, I'm just sort of drawing this arbitrarily, is about there, 2 is about there, and we'll say 3 is about there. Okay, so this is 33 because you add the standard deviation of 4 to it.
Mm-hmm.
You add the standard deviation of 4 again, and 4 again. And then you got to go the other way and do the same thing. So that's 25, 21, and 17. Okay. Now, do you know the percentages that go in each of these?
I know it's like 30 something and then 13.5.
Yes, I feel like we're guessing, and we
It
definitely don't
does
want to
not work.
definitely don't want to do that. Here's whoa, that didn't work. So I wanna just snip in a nice one here, so you have it for your notes.
Oh yeah, I got 13.5.
Yeah, well, that's fine here. So what I would do is have you draw these in. If you get a note sheet, I would definitely have this in there.
Okay.
This is 2.35, and this is 0.15, and so on. This is 13.5, 2.35, and then 0.15. So now we can answer some questions because
Yeah.
the if you don't have this, you're kind of not sure what do I do next. So because at this point, when you get the question, you're just adding up windows or intervals here. So from 25 to 33 is these two intervals. So that's 34 plus 34. That's 68%. Greater than
Okay.
29 is everything to the right. Now you might already know that it's 50%, but if you add these up, you get 50%. Because your instructor could just as well say 21 to 33 or 17 to 37 or 17 to 25.
Yeah.
You'd have to do these windows. Great. Okay. Number 15, it says to describe the bias. Newspaper wants to take a poll about which candidate voters prefer for president. Identify any bias in each sampling method. So the newspaper interviews people at a political debate.
Oh, like what type of bias?
Yeah, and do you have a list of what you guys actually covered for that?
I do. I'll pull it up.
Because there's many, and it depends on
What?
your class, your instructor.
Yeah.
So you're choosing a word here, and then you usually have to describe why that word applies.
Uh-huh.
So, like for example, here, you could say that the bias is that the people at a political debate are going to be much more charged up about it than maybe the average person because they're deciding to go to the debate.
Yeah.
I'm not sure what that is, but that is what those are the kinds of words the instructor is looking for there. You should be prepared to write some sentences if you get a question like this in the exam. So number 16, the newspaper calls people selected at random from the local telephone book. So the main thing here is if you're not listed in the telephone book, you're not going to answer.
Uh-huh.
So your bias is that you only sample from people that have their information in the telephone book.
Yeah.
And that it could be a problem.
Mm-hmm.
All right, so at a high school, 30% of the students buy class rings. You select 5 students at random, find the probability. Okay, so now we get a little bit harder questions here.
Yeah.
Let me just check something real quick. Okay. All right, so high school, there's exactly 2 buy rings. Okay, this is a binomial distribution. And the reason you know that is because they either buy or don't buy,
Mm-hmm.
and there's only one or the other. That's like they're mutually exclusive. Okay, so the probability that they buy is 0.3. The number of students that you select is 5, and you're trying to find the probability that x equals 2. Now your calculator has a binomial distribution feature in it. Do you recall if you've used that or not?
I don't know. Do you know where it would be?
Yes. Let me. I'll snip in how to find it.
Okay.
So that you can. I don't have one in front of me, so it's under. It's gonna be like under stat distribution.
Okay.
Okay. So it is second vars. Let me snip this in here. So there's 2 of them. So you go second vars, and then in this case you want PDF, and I'll explain that in a moment why you want PDF. Okay. So when you get to that screen, okay, you have to choose. You have to choose what you're going to put in there. So the options are the number of trials, p, and the x value.
Yeah.
So we scroll back up. The number of trials is n. The p is 0.3, and the x value is 2. 5, 0.3, and 2.
Oh. Okay. I got 0.3.
Exactly 0.3?
0.3087.
Okay. Usually they want you to get like 4 decimal places on that.
Okay.
Okay, so that's part A. That's this one. Exactly 2 rings. The probability that they buy at least 2 rings is the probability that x is greater than or equal to 2. Okay, so there's a couple ways to do this. You can do 2 means it's the probability that x is equal to 2 plus the probability that x is equal to 3 plus the probability that x is equal to 4 plus the probability that x is equal to 5. So you could do this 5 times. I'm sorry, 4 times. What you just did. You'd have to do it for 2, and then you change this number to 3, then you change this number to 4, then you change this number to 5, and you'd add up all the results. That's one way to do it. Okay, it's not the best way, but it's one way to do it.
Yeah.
The other way to do it is to use this Binom Cdf.
Okay.
Okay, so the way you'd use Binom Cdf, it's the same thing, but there's a little bit more of a work involved because you have to understand the probability that x is greater than or equal to 2 is equal to 1 minus the probability that x is less than or equal to 1. So let me try to explain that. 0, 1, 2, 3, 4, and 5. These are the possible outcomes that you could have in this particular example. So greater than 2 is 2, 3, 4, and 5. less than or equal to 1 is 1 and 0. So if you don't include those outcomes, you get the ones above it.
Yeah.
1 minus those. So if you do a Binom Cdf, I'm going to copy this over. What isn't? Okay, that's weird. So if you do it this time and you go 5 trials, p-value of 1, I'm sorry, p-value of 0.3, x-value of 1, whatever number you get here, you're going to have to do 1 minus it to get the one above it.
Okay, so I got 0.5282. So I do 1 minus.
Yeah,
0.5.
yes, yes.
Okay, so it's 0.4718.
Okay, so that's that takes care of those, and we'll move on to 18. Okay, so I sort of talked about this earlier. Which situation involves a combination or a permutation?
Mm-hmm.
So permutations, order matters. I'm gonna write that down, but that's the key difference. So order arrangements matter. Okay, so permutations, order matters. So let's look at B first. B is a permutation. Why would order matter? Well, if you have the numbers 1, 2, 3, 4, 5, 6, 7, 8 is your combination and you enter 8, 7, 6, 5, 4, 3, 2, 1, this one won't work because the code has to be done in a certain order, just like your password for your email or anything else has to be in the right order.
Mm-hmm.
Part A is a combination. Why would that be? So you're choosing a team. So let's say it's team members A, B, C, D, E, and F. And then another team is A, D, E, F, A, B, C. These stand for people's names. Is this the same group of people each time?
Yeah.
Yeah,
because it doesn't matter which order they get picked.
That's right. So order not matter, and that's what you have to convince yourself of when you're writing the answer.
Mm-hmm.
You have to convince yourself that okay, I'm right because order doesn't matter or order does matter, and so on.
Got it.
Okay. All right, number 19. Okay, so we actually already did this, but we did it with different numbers. Data set is normally distributed with a mean of 37 and a standard deviation of 8.1. So the 37 goes right down the middle. And 1, 2, and 3 standard deviations. I mean, so the key here is to get these in a reasonable place. There's 1 standard deviation, there's 2, there's 3. You don't want them all too tight, like or bunched up. They got to be sort of the same distance apart. So you're just adding 8.1 each time. So this is 45.1, 53.2, and then 61.3. And then now you got to go the other way. And the only thing that's I think is harder about this is you're just subtracting.
Yeah.
Which just it's not as easy to do. So you subtract 8, that's 29. So this is 28.9. Subtract 8.1 again, you get 20.8. Subtract 8.1 again, you get 12.7 for that.
Okay.
And then you can throw in those percentages if you want. It doesn't ask you for that, but you could throw them in, like the 34, 13.5, and so on. That's it for that.
What's the one after 13.5?
2.35.
Okay.
2.35, and then the last one is 0.15. 0.15.
And we just have to draw it?
All it says, sketch.
Oh, okay. Nice. All right, so we have a bit of time. Maybe we could do some more like word problems on combination and permutation. Just
Sure, I'll find one and I'll see if you can. All right, so I'll just, I didn't find what I wanted, but I've got a question or two I can pull up. I want you to decide whether this is a permutation or a combination.
okay.
Let me know when you got a decision on that.
I think it's a permutation
Okay, why is that?
because like if first place and then there's only like 7 more spots to take up second place. Is that
Okay.
right?
It is a permutation, so I like to think of this as like, let's say there's a prize for winning. A and B finish first and second, or B and A finish first and second. Does it matter? Let's say the first prize is a pot of gold, like at the end of a rainbow. Do you want to be A in this case, and you want to be B in this case? And that's how you can think about this. So the order definitely matters here because you want to make sure that you're first.
Yes.
Just what I'm looking for are some word problems that actually ask this, but I'm not finding like ones that aren't already kind of there.
Okay.
Let me find another one here. I'm looking for like a synthesis where it mixes the two.
Mm-hmm.
Which I'm not finding. Let me look at one more resource here, and otherwise I'll just give you some more sort of words to go around it.
Okay.
Same exact thing. Okay, so I'm not seeing it. So permutation problems, you're looking for the words like arrangements, order, places. So some examples are like bookshelves, where you put books on a shelf or something in order, sitting around a table positions, um, winning a race, president, vice president, secretary. Those are permutations, things like that. Combinations, we keep saying when order doesn't matter, these are generally like groups.
Mm-hmm.
And like you have to decide, does the group consisting of the same people, like we mentioned, like is A, B, C the same as BCA? If it is, then this is a combination.
Mm-hmm.
Like where so let me think of yeah I'm sorry, I can't find. I used to have have something that would come up right away that just asked a bunch of these, and then I could just
Yeah, no worries.
Okay, what else can we cover here?
There's that thing, I forgot what it's called, but how you like subtract 1.5 or like can we go over that? Do you know
Yeah,
what I mean?
well, that's kind of related to question 11. I don't know why they didn't
Do that part?
or do that part. They didn't ask at all about a box and whisker plot, but let's do it for
Yeah.
this one. Doesn't look like there's going to be any outliers, but we'll do it anyway. So out of so Q1 is equal to 42, and Q3 is equal to 69. So the interquartile range IQR is Q3 minus Q1. 69 minus 42, which is 27. Okay. The lower fence is Q1 minus 1.5 times the interquartile range. So your Q1 is
Okay.
42 minus 1.5 times 27, not 2.7. So 1.5 times 27 is 40.5. This ends up being 1.5. And so there's no values below it. So there's no outliers there on that side. The upper fence is Q3 plus 1.5 times the interquartile range. So this time it's 69 plus 1.5 times, I don't know why I keep doing that, 27. Whatever number you get here, you're either subtracting it or adding it. If you're adding it to different numbers. So the what did I see here? 40.5. So this is 109.5. There's also no outliers there for that. So you really need to have these formulas down.
Yeah.
So that in case you get a question like this, you can do something with it.
Okay. Yeah, that makes a lot more sense.
Okay. What else would you like to cover here?
I think that was it mostly.
Let's do a quick contingency table if you're okay.
Okay.
Okay, so we'll go 13, 5, 6, and 20. Okay, so what's the probability of boys in this?
13 out of 20.
So boys is this whole column. So what's missing is the total. I intentionally left that blank because it wasn't included in the problem we did. So we did a problem earlier where you had to find the totals. Sometimes they're given, but this time they weren't.
Okay, so it's 13 out of 18 then?
How many boys are there? What's the total here going down?
18.
Okay. What about this total for girls?
26.
Okay. And what about this way?
19, 25.
Okay. So how many boys are there?
18.
Out of how many total?
44.
Okay. So what's the probability of dogs? How many dogs are there?
25.
Out of?
44.
44. Now, what you might have been thinking about is what's the probability of a cat's given boys? So the given changes this bottom number. Like the bottom number is not going to be 44. It's going to be how many boys are there?
18.
18. And then how many of those have cats?
13.
13. What's the probability of dogs given girls? So how many girls are there? That's what changes this time.
20 out of 26.
20 out of 26. Very good. Okay. This will be on the exam. I mean, something like this.
Yeah.
So you have to be comfortable doing this. I don't know what it'll be. I mean, it might be I mean, I made it silly, but that's what it could be.
Mm-hmm. Yeah, I just have to remember to put the totals in, because if I don't, that's gonna make sense.
So the when it's just one thing, it's generally the super total.
Mm-hmm.
When it's a given, it's either the column or the row total.
Okay.
Is there anything else you would like to cover?
Let me see here. I don't think so. This chapter doesn't have much.
It does not. It does not. You have an opportunity to really do well. It's not that much. If hopefully it's similar to this, whatever you got on your exam.
Yeah. Yeah, I just have this last test and then I have my final. So
Great. Well, you're almost
yeah.
there. Almost there.
Mhm.
Okay. Well, we can stop here, and I'll send the notes and the screen recording out shortly.
Okay, thanks.
Thank
See you
you.
next
Great night.
week.
Okay. Bye now.
Bye.